Hello everyone, welcome to section 5.1. Today we're going to be talking about the unit circle, or this will be our first lecture in the unit circle. The unit circle is one of the best tools we have when studying trigonometry. Here we think about trigonometry as actually points on a circle of radius 1. Let's go ahead and get started. So let's just draw a circle of radius 1. So this will be our y, this will be our x. Let's put 1, a 1, here we'll have a negative 1, here we'll have a 1. I'm going to attempt to draw a perfect circle. Not perfect, but close. So our main goal, at least for right now, we want to find the x and y coordinates of a point on the unit circle. Okay, so let's think about a nice relationship, or a relationship between x and y that has to do with a circle of radius 1. Let's grab a random point on the circle right here, and let's think about its x and its y coordinates. So what we know that is true is that it doesn't matter where I am on the circle, the length from the origin to a point on the unit circle, the radius will always be 1. So notice that actually circles and triangles are best friends because whenever or wherever I am on the unit circle, I can always draw a right triangle. Circles and triangles are best friends. So we'll have that this will be the x coordinate, and over here, this is the y coordinate. So let me kind of draw this height will be y, and this length here will be x. So what must be true about any single point on the unit circle? Well, if we think about the Pythagorean theorem, we must have that x squared plus y squared is equal to 1 squared. X squared plus y squared is equal to 1 squared, or x squared plus y squared is equal to 1. We need to remember this. This is a piece of math we need to keep in our math pocket. So whenever I'm talking about the unit circle, we'll always be thinking to ourselves, what is true about a circle of radius 1? Any point that's on a circle, what must be true is that if we square the x coordinate and add the y coordinate squared, we'll always get out 1. Let's do some exercises to get us used to working with the unit circle. Okay. Let's go ahead and draw the unit circle over here. Oh, we do it over here just a little bit smaller. So I guess just a little bit more language I'd like to talk about. When I have a circle of radius 1, it's split up into 4 different quadrants. We call this one here quadrant 1. We call this quadrant 2. This one here is quadrant 3. And this will be quadrant 4. Now, oftentimes we'll always want to think about where we are in the unit circle, what quadrant we're in. And let's think about what's true about the x and y values in each of these quadrants. If I'm in this quadrant here, notice that the x value and the y value are both positive. So x is positive and y is positive. In quadrant 2, the x coordinate is negative and the y coordinate is positive. What's true about the third quadrant is that both the x and y coordinates will be negative. In the fourth quadrant, the x-coordinate will be positive and the y-coordinate will be negative. So let's do an example. I guess we have a question. Is the point -5/7 and -2 root 6 over 7 on the unit circle? So that's our first question. Notice if it is on the unit circle, we'll verify that it is. Notice that both the x-coordinate and the y-coordinate are negative, so this point here, if it lives on the unit circle, would live in quadrant 3. So to verify that this is on the unit circle, what must be true is that the x-coordinate squared plus the y-coordinate squared must be equal to 1. So if this point here satisfies this equation, then it'll be on the unit circle. So let's take the x-coordinate, -5/7, let's square that, plus the y-coordinate squared. Let's see what we get. Well, whenever we square a negative number, it becomes positive. If I square the 5, I think I'm going to get a 25. Square the 7, I'll get a 49. Plus. Okay, so if I square -2 root 6, if I square the -2, I get a positive 4. If I square the root 6, I'll just get out a 6. And if I square the 7, I'll get out a 49. So it looks like we have 25 over 49 plus 6 times 4 was that 24 over 49. So since we have a common denominator, we can add the numerators. We have 25 plus 24 over 49. So 25 plus 24, that's 49 over 49, which is 1. Yes! So we have that this is 1. So this point here is on the unit circle. Smiley face. Okay. Let's do one more example. Is -√7/3 and 2/3 on the unit circle? Go ahead and pause the video and give this a shot on your own. Okay, so the first thing I'm going to notice, or what I'm going to think about, is, I guess we don't really need it for this problem, but it's good to think about, is the x-coordinate is negative, the y-coordinate is positive. If this point is on the unit circle, it would be living in quadrant 2. Okay, so to see if it is on the unit circle, we'll check if x squared plus y squared is equal to 1. Okay, so -√7/3 squared plus 2/3 squared. If I square -√7/3, I'm going to get a positive 7/9. If I square 2/3, I'm going to get a 4/9. So we get a 7 plus 4 over 9, or we get an 11/9, which is not equal to 1. So this point is not on the unit circle.